project a personal spending tracker that allows users to manage their day-to-day spending, budgets, and recurring payments in one place. For the schema, at a high level, the system models user, their bank accounts, and their spending. Each user has a unique username, password, and address, and each user owns one or more bank accounts. Every account belongs to exactly one user and stores the bank name, account number, and account type. Spending is organized through vendors, categories, and transactions, as well as budgets and recurring rules. Each transaction links to exactly one account, one vendor, and one category, so it can always be tracked back to a specific user. Budgets track planned versus actual spending per category over a date range, and recurring rules represent repeating payments like electric bills or membership, which can automatically generate new transactions over time. For the architecture, the project is built on MySQL with the Python command line application on top. MySQL stores all the tables and most of the logic, including database functions that allows automatically update the generate next due date, and stored procedures to create and list data, trigger to keep the actual spend field updated, and a scheduled event to apply recurring rules. So the Python script connects to MySQL using the Python MySQL library, shows a text menu, and calls those stored procedures and functions. So the database enforces the rules and calculations. The Python layer mainly handles user input, menu navigation, and displaying results. So from the user perspective, this is a simple spending tracker they run in the terminal after logging into MySQL and entering an application username. For example, in our case, if we go to the user table, we'll see we have 3 current user. Let's say we use user ID number 3, T Peterson, and enter the password. It will display a menu for Tom. And let's say first we want to view the budget with the current budget. We got 6 transactions. And if we want to validate, we can go back to the schema and run a select statement and see those 6 records match each other. And next we can add a new manual transaction. So let's say we want to do $100 for 2024, February 15th, and description would be dinner at Chipotle. And the menu will display the user's current bank account selections, available vendors, and categories, so the user don't have to memorize the ID for these items. So let's say we want to do, so for account ID, 5 is the only option, and it would be 7 for the vendor and 2 for the category. So let's first check if this transaction already exists in our database. So we do not have a current transaction for dinner at Chipotle. And if we go back to the budget, we will see we have a category 2, and the date range is from February 1st to 29th. So we do have a $300 budget with $118.9 actual spent so far. So after we insert the transaction, the amount should be increased by $100. So let's insert the transaction now. Vendor ID is 7 and category would be 2. Okay, so it says transaction created successfully. We can view the transactions again here. We see that there's a transaction 30. That's the transaction we just updated for dinner at Chipotle. And if we go to the transaction at data schema, yeah, we see the transaction 30. And let's check if the budget actual spend increased by 100. Yep. So all three records were updated. And lastly, we will do a delete for delete of the transaction that we just added. So let's do option 8, and it will display the current transactions, which 30 is the one we want to delete, and we enter 30, and it will confirm. And then transaction deleted successfully, and we'll view the transactions again. Transaction 30 is gone. And if we go back to the transaction, there's no 30. If we go back to the budget, the amount actually decreased by $100. So these are all the three operations examples. So to summarize, this project combines a MySQL schema, database programming objects, and a Python command line front end to give user a simple but also complete personal spending tracker.